Hey, geometry students, welcome to chapter 7 and 7.1, ratios and proportions. So here we go. Got a couple or several definitions and then some questions to jump into. So let's get to it. All right. First of all, what is a ratio? Well, ratio is simply a comparison of two numbers, often shown in the form of division. And comparison of two numbers, but even usually it's, those numbers signifying two amounts. So, for example, you might have something like inches to feet. So that's a common ratio because we know that 1 foot is the same as 12 inches, or there's 12 inches in 1 foot. And so that's a ratio, 1 to 12, 1 foot to 12 inches. So any of those conversion rates would be a comparison of, again, centimeters to meters or miles to yards or anything like that. So that's a ratio we would say of 1 to 12 or 1 foot to 12 inches. You might see this with miles per hour. So any sort of a rate like that, where you're driving 60, or we'll say 30 miles per 1 hour. So 30 miles an hour is a ratio of 30 to 1. Or you might have a ratio of, if you're looking out and you're counting things and you're watching cars go by, and you might think, okay, so in 30 minutes there were three blue cars, cars for every 5 white cars. So you're just comparing two numbers of things. And we'll develop this, but a very basic thing, a ratio, or actually this is the one the book gives, a slope, where you have rise to run. That is a ratio of the number of rising units compared to the number of running units. So that is also a ratio. And these are all written as like fractions or with division. But we can write them two other ways, but we'll get to those when we get to the questions. All right, next definition. So a proportion. Well, a proportion is an equation stating that two ratios are equal. So for example, you could have, if we have a ratio of, we'll go back to the 12 feet one, 1 foot for every 12 inches. Okay, that's a ratio, and that is equivalent to another ratio of, say, 2 feet for every 24 inches. So those are two ratios that are equal to each other. And again, I've written the units in, but you could also just write that without the units and say 1 to 12 is the same as 2 to 24. And we'll get into comparing, solving proportions and showing how you can create proportions. But right away, you can start to see that's a true proportion because the 1 doubled equals the 2, and also the 12 doubled. There's a proportional relationship between the top two numbers and the bottom two numbers. Then you'll learn to identify those to know if things are really, if two ratios really are equal to one another. Okay, or here's even another example, but you can already see it, is that ratios can be expressed, or they're kind of like fractions. So if we said something, say you have a ratio of just, let's go with 20 to 5, you could think of that as, we could reduce that. If you divided both of those by 5, you would get 4 to 1. Okay, and whenever you have two ratios that are equivalent with an equal sign, that's what we call a proportion. And again, we know they're proportional because you can see, okay, this was divided by 5, and this was also divided by 5. And so they are, in fact, equivalent. Okay, so a proportion is basically an equation with two equal ratios. Then cross products, okay? So what are cross products? Cross products are when you take a ratio, and I'll go ahead and maybe I'll just do the one that I did, 20 over 5 equals 4 over 1. And the cross product is when you multiply across. We call it cross multiplying. So if I multiply like this, 20 times 1, I get 20 equals, and then 4 times 5 equals 20. Notice I get the exact same number. And so that is a sign of a true proportion. So when the cross products are equal, your proportion is true. Say, for example, I had something that was more like let's see, 3 to 5 is equal to 7 to 9. Okay, and you want to know, well, let's see, are those actually, is that a true proportion? Are those actually equivalent? Well, what you do is you just check the cross products. And you go like this, and you say, okay, so 3 times 7, or 3 times 9, I'm sorry, is 27. Is that in fact equal to 5 times 7? No, well, that's 35. So by checking the cross products, not proportional. So that's the big value of cross products, is that you can identify quickly. And again, sometimes the numbers are so easy it doesn't seem necessary, maybe like the 20 to 5 and 4 to 1. But when the numbers get bigger and you're a little less comfortable with them, a quick cross multiplication will immediately tell you if they are in fact proportional or not. Going back real quick to proportions, just want a little bit of vocabulary here, and that is when you have a proportion like, let's go ahead and just say, let's go 1 to 12 is equal to 2 over 24. Some key terms are that the first number and the last number, these are called the extremes. And the middle numbers, so the bottom and those right there, these are called the means. And so again, going to the cross products, you find that a cross product is simply multiplying the two extremes by each other and seeing if they equal the multiplication of the means. All righty, let's get to our questions. So question number 1 asks, what are 3 ways to write a ratio? Well, we know one of them. We know that 1, you can write them as a fraction, okay? You can also write them with a colon, so 3 to 5. Those would be equivalent ratios, 3 to 5 as a fraction, or 3 to 5 with a colon in between. Or you can just spell it out. So sometimes it'll be written as 3 to 5. Okay, all 3 of those are equivalent. You'll see it in all 3 different forms. And again, the order does matter. 3 to 5 is not the same as 5 to 3 because that 3 represents something specific, and so does the 5. And if you reverse it, well, now all of a sudden you're changing the meaning, whether that's inches and feet or whether that's blue cars to white cars or whatever the 2 things are that you're comparing. Question number 2 is just reinforcing what I've already stated, and that is ratios can be simplified just like you would simplify fractions. So if you see a ratio like this, 12 to 9, you can think of, well, these are both divisible by 3. If I divide both of these by 3, then that's going to leave me with 4 to 3. Okay, and so 4 to 3 and 12 to 9 are in fact comparable, and it's just like reducing, like you would reduce a fraction. And again, you can even check that. If I were to write it, say, this way, 12 to 9 is equal to, and again, the order matters. Notice in this case, I'm putting the first number on top, is the same as 4 to 3. If I quickly check the cross products, I can see that 12 times 3 is 36, and that 4 times 9 is also 36. And so I can see, yes, this is correct. This is in fact equivalent to the other one. Okay, so number 3 asks, identify a real-life ratio in your life. Okay, well, there's all sorts of these, but if off the top of my head, you could do a comparison of, say, your fingers to your toes. So if I were to compare fingers, on a person's body, fingers to toes, they have 10 fingers and they have 10 toes. So it's a ratio of 10 to 10. That's the same as a ratio of 1 to 1, because again, they can in fact be reduced. And again, you could also write that like this, or you could write it like so. Okay. Okay, let's see. Question number 4. This is a ratio of girls to boys in the classroom, and it doesn't reflect our class, but just imaginary. But that's another thing you could easily compare. If we had 20 girls in our class, how many boys would be needed to create a ratio of 5 to 3? Write a proportion. Okay. Well, so we want the ratio. Let's start with the ratio wanted. They want a ratio of 5 to 3. So I'm going to put the 5 on top, 5 to 3. And again, the 5 is the girls, the 3 is the boys, and that's equal to, if there were 20 girls, you've got to always make sure your like ones are across from each other. And then they want to know the unknown quantity is, well, how many boys? We don't know. So to preserve that ratio, how can we do it? Well, when the numbers are manageable, you can kind of just look at it and say, well, 5 times what would give me 20? And if you can see that relationship easy, you can say, okay, well, 5 times 4 gives me 20. So let me just do 3 times 4. And that means, okay, that tells me very quickly 12 boys would be needed to make it equivalent. Okay, so if you can see what was multiplied or divided to change the ratio, then just repeat that for the unknown quantity and you can get the answer. 5 to 3 is the same as 20 to 12. And you can even see if you had the fraction of 20 over 12, it reduces by 4 to 5 over 3. In cases where the numbers are more difficult, and they will eventually, you can use the cross products. So I could simply go and say, okay, let me multiply across like this and say 5 times x, because you get 5 is equal to 3 times 20, which is 60. And then you get a very simple equation to solve. You can say, okay, 5 times x equals 60, so let me just divide by 5. And I can see that my missing number is 60 over 5, or that is, in fact, 12. Okay? So when numbers are trickier and you can't see it right away in your head, you're just going to learn to cross multiply to the cross products and then solve the equation by dividing. We call that cross multiply and divide, and you'll get very good at that. Okay, so 12 boys outnumbered by the girls. All right, and then number 5 is a problem right out of the book that I want to demonstrate, because when you first see it, you might be tempted to panic. You'll be like, what on earth? How do I do this? And there's questions like this on the SAT. And they're actually very simple if you have just the simple strategy for how to approach them. So number 6 says the ratio of the side lengths of a quadrilateral are 2 to 4 to 5 to 7. So those are the comparing, those aren't the distances, they're the comparing of each of the sides to each other. So it's like you have one side that's 2, one side that's 4, actually I should do that in order. That's 4, another that's a little bit bigger at 5, and another one that is 7. And again, those are not the lengths, but that's how the lengths kind of proportionally compare to each other. And then it says that the perimeter is 36, so they add up together to be 36 meters. And you can see those can't be the distances because 2 plus 4 plus 5 plus 7 do not equal 36. So how do you approach a problem like this? Well, the easiest way to do it is to realize there is a since all the numbers are proportional to each other, they're just somewhat either bigger or smaller than what they are. We can simply add an x and express the sides like this: 4x, 5x, 7x, and 2x. Because we know that will maintain that proportion, but allows us to find the actual length. Because now also by adding an x, we can write an equation. Because perimeter is simply all of the distance all the way around a shape. So I can say, okay, so 2x some side plus the 4x side plus the 5x side plus the 7x side equals the full perimeter of 36. All right? Because you just add the 4 sides and that's all the way around. So it's combined like terms. 2 plus 4 plus 5 plus 7, that's 6 plus 5, 11 plus 7 is 18. So we get 18x equals 36. Just divide both sides by 18. And so we can see that x equals 2. So again, that means the real sides of the shape are not 2, 4, 5, and 7, but all of those ratios multiplied by 2, 4, 8, 10, and 14. So going back to the problem, it says, what's the length of the shortest side? And so that would have to be the 2 side. So that's just, we just plug in the 2 there. And so the shortest side is 4 meters. Okay, so whenever you get a problem that gives you the proportion of the sides, even if it's area or perimeter, if they give that to you, just put an X after it and then begin to work on it as a typical algebra problem. Okay, all right, look forward to discussing this in class. Proportions are and ratios are very practical, very useful in real life, from cooking to simple measuring and construction and building of things. So unit conversion, all of these things. So it's of a lot of the things we've studied, I can honestly say this one's very practical. And so look forward to covering it with you guys. See you in class.